Next is the push broom sensors. So the left image here shows the whisk broom sensors. And then the right one shows these kind of push broom sensors with much simple, so less motion. You just, while your satellite is moving and you are just scanning through the ground without mirror rotation. So that's a simplification of the image acquisition process. So in one of the early Landsat missions, one of the known problem with the Landsat dataset using the whispering method is sometimes they create a problem with the georeferencing. Like for example, this image on the left side was supposed to look like on the image on the right side, but because the registration issue, they may appear, the initial data without processing may appear like this. Okay, so later they improved Landsat to this kind of push broom sensor. Multispectral imaging using the linear array system, which is push broom system, include these Landsat, Spot, and Aster, QuickBird, Iconos, and others. So we're just going to have a look at these sensors. So Landsat 8 carries two push-broom instruments, the operational land imager, OLI, and thermal infrared sensors. So these are the spectral band. So as you can see that they have aerosol, coastal, visible blue, visible green, visible red, near infrared, shortwave infrared, two shortwave infrared, panchromatic with 15-meter resolution, and long circles and long wavelength. So the multispectral band area has the same 30-meter resolution. So that's the Landsat 8. Um, so notice that Landsat 8 have relatively more bands from the previous missions. So you need to be careful when you stack image together, sometimes they may report a problem saying that the data volume may be over the limit. So you need to have special type of data set will be able to store these kind of larger data volume data set. The spot sensor system is developed by French, and it's a reliable source for high resolution image since 1986. And so there was a time 10, 20 years ago, people would buy high resolution spot image for their GIS data mapping. So these are example of different generations. As of nowadays, the latest mission is the Spot 7, launched in 2014 and ended in March 2023. So this is how the sensor may look like. One of the unique characteristic with the Spot sensor is that they have this kind of side-looking, not only they provide nadir-looking images, but also off-nadir collections. So they use this kind of approach to generate stereoscopic images for three-dimensional mapping, as well as increase the revisibility, the temporal resolution of the dataset. And so this is the parameters listed for different generations up to Spot 5. So it gives you a good example to see how spatial resolution has increased from 20 meter to 10 meter, and then now the 1.15 for Spot 5. But as of nowadays, they have Spot 6 and 7, provide a 10-meter localization accuracy, and color will be 1.5, black and white 1.5. Multispectral will be 6 meter. So that is the general resolution for this data set. This is comparison of Landsat dataset, 30 meter versus 10-meter resolution. So comparing to Landsat is great improvement for spatial resolution. And this is example showcase the Spot 6, 1.5-meter resolution. This is the Terra instrument have different camera sensors on it. So including the advanced spaceborne thermal emission and reflection radiometer Aster, and clouds and earth radiant earth system, and multi-angle imaging spectral radiometer, the MODIS moderate resolution imaging spectral radiometer, and measurements of pollution in the troposphere. So in this sensor, the most frequently used one are the ASTR-DM and MODIS dataset. So this is the parameters for Terra orbit parameters. So basically, they also have the sun synchronous mission with orbit with altitude of 705 and inclination of 98.6, inclination of 98.2 degree, and repeat cycle is around 16 days. Basically, it's the same orbit parameter with Landsat dataset. So they have these Terra sensor launched in 1999, offer this ASTR dataset. It's a cooperative effort between NASA and Japan. They offer 50-meter visible, 30-meter shortwave infrared, and 90-meter thermal infrared, 60-kilometer swath, and 16 days repeat cycle. So, this ASTR dataset is often used in conjunction with MODIS, MIST, or CRES sensors that monitor Earth at moderate to poor spatial resolutions. And ASTR is most well known for its global DEM with 30-meter resolution, which is free, which means that if you do some large-scale study, you are guaranteed that you can find some 30-meter resolution DEM dataset for your study site. So this is the parameters for the ASTR, Advanced Spaceborne Thermal Emission and Reflection Radiometer, with 3 different camera systems on it. So as you can see that it's a push boom sensor with 15, 30, and 90-meter resolution and 8-bit. So the radiometric resolution is 8-bit, 8-bit versus 12-bit. So this is example showing ASTR near-infrared image of Pearl Harbor, Hawaii at the 15-meter resolution. And this is use of thermal image in band 14 for the lava flow monitoring on Hawaii with a 90-meter resolution. And this is application for Death Valley analysis. As we know, Death Valley is one that's very dry and doesn't have much of vegetation cover. So therefore, different spectral band information is very critical for analysis. So this is how the data may look like different images, different sensors. And this is example to use the thermal image to measure the temperature distribution. This Death Valley, so example that you can also drape the image composition on top of DM, so that way will be much easier to help you interpret what is going on and also interpret landscape in the area. So this example for 30-meter global ASTR DM, how they look like. So it's a widely used data set for large-scale modeling.